Hi listeners, you are welcome to the continuation of our online tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAMB, WAEC, NECO and NAPTIP exams. For today's presentation, we shall be discussing the concept of general gas equation. I am Bangbade AA. Now, before we proceed, we need to consider the learning outcome of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to state the mathematical expression for the general gas equation. They should also be able to interpret the parameters of the general gas equation. And lastly, they should be able to solve relevant UTME questions relating to general gas equation. Now on to the mathematical expression for general gas equation. The mathematical expression for general gas equation is given as P1 phi1 over T1 equals P2 phi2 over T2. I repeat, the mathematical expression for general gas equation is given as P1 phi1 over T1 equals P2 phi2 over T2. Again, P1 phi1 over T1 equals P2 phi2 over T2. Now, the P1 here is initial pressure. The phi1 here is initial volume of gas. The T1 here is initial temperature in Kelvin. Now, phi2 will represent the final pressure. Phi2 is final volume and T2 will be final temperature in Kelvin. Again, P1 here represents initial pressure. Phi1 represents initial volume. T1 represents initial temperature in Kelvin, not degrees Celsius. So if you are not given in degrees Celsius, it must be converted to Kelvin. Now, P2 represents final pressure. Phi2 represents final volume. And lastly, T2 represents final temperature in Kelvin. The temperature must be in Kelvin. Now on to sample questions. The first question we shall be considering comes from UTME 1989, number 15. And the question goes thus. The mass of a gas at 7 degrees Celsius and 70 centimeters of mercury has a volume of 1200 cm3. Determine its volume at 27 degrees Celsius and pressure of 75 centimeters of mercury. We are given option A to be 1200 cm3, option B to be 1378 cm3, option C to be given 4230 cm3, while option D is 4629 cm3. Now on to solution. As usual, the first step is to write out the given parameters, and from the question we are given the initial temperature T1 to be 7 degrees Celsius. Well, on converting it to Kelvin, we are going to add 273 Kelvin. So our 7 degrees Celsius in this case will be equal to 7 plus 273 Kelvin, making 280 Kelvin. Also, we are given the initial pressure P1 to be 70 centimeters. Then we are given the final temperature T2 to be 27 degrees Celsius. As usual, we add 273 Kelvin to convert it to Kelvin. Therefore, at 27 degrees Celsius will be 27 plus 273 Kelvin, making 300 Kelvin. Now, we're given the initial volume to be 1600 cm cube, while the final volume is not given. The initial pressure is 70 cm cube, while the final pressure is 75 cm cube. Now, after knowing the given parameters, the next is to proceed to the formula, the mathematical expression for general gas law or general gas equation, which is P1 V1 over T1 equals P2 V2 over T2. So in substituting for the parameters there, we will have P1, which is 70 centimeter, times V1, which is 1200 cm cube, over T1, which is 280 Kelvin, equals P2, which is 75, times V2, which is unknown, over T2, which is 300 Kelvin. So we can cross multiply to get 70 centimeter cube times 1200 cm cube times 300 Kelvin will be equal to V2 times 75 then times 280 Kelvin. Then we can make V2 the subject of formula by dividing through by 75 times 280 Kelvin to get V2 equals 70 centimeter times 1200 centimeter cube times 300 Kelvin divided by 75 times 280 Kelvin. So if you evaluate this, our V2 will be 1200 centimeter cube, making option A the correct answer for this particular question. Now, the next question we shall be considering comes from UTME 1993, number 16. And the question goes thus: when the volume of a given mass of gas is halved and its temperature doubled, the pressure dash A remain constant, B increases by a factor of 4, C increases by a factor of 3, D decreases by a factor of 4. Now to solution. The first step is to write out the given parameters, and from the question we are told that the volume is half. That means the final volume is half of initial volume. Therefore, the final volume V2 will be equal to 0.5 V1. That is half of V1. Then also from the question, we are told that the temperature is doubled. Therefore, the final temperature T2 will be 2 times initial temperature T1. Therefore, T2 equals 2T1. Then they ask us to get the final pressure P2. Now let's proceed to the substitution in the formula. Then as usual, using the equation P1 V1 over T1 equals P2 V2 over T2. So our P1 times V1 over T1 will now be equal to P2, which is unknown, times V1 times V2. Our V2 is half of V1, therefore our V2 in this case will be 0.5 V1, then over T2, which is 2T1. So which is 2T1. Then when you cross multiply, it will have P1 V1 times 2T1 will be equal to P2 times 0.5 V1 times T1. Then we'll make P2 the subject by dividing through by 0.5 V1 and T1. Then that will give us P2 equals P1 Phi1 times 2T1 over 0.5 Phi1 times T1. In this case, Phi can cut Phi. Then T1, Phi1 can cut Phi1, T1 can cut T1. So that will be left with 2P1 over 0.5. And that will give us P2 equals 4P1. Now that means the final pressure is 4 times initial pressure. Now the question asks us that by what amount from the option now. That means if our final pressure is 4P1, if we want to know the increase in pressure, we subtract P1 from P2. And since our P2 is 4P1, when we subtract P1 from it, our P2 minus P1 will be 4P1 minus 3, which is 3P1. And that means the pressure increases by a factor of 3, making option C the correct answer for this particular question. The next question we shall be considering comes from UTME 2001, number 16, and the question goes thus. The pressure of a given mass of gas changes from 300 Newton per meter square to 120 Newton per meter square, while the temperature drops from 127 degrees Celsius to minus 73 degrees Celsius. The ratio of the final volume to the initial is dash. Option A here is 2:5. Option B is 5:4. Option C is 5:2, while option D is 4:5. Now on to solution. So as usual, the first step is to write out the given parameters, and from the question we're given the initial temperature to be 127 degrees Celsius, which will convert to Kelvin by adding 273 Kelvin. So 127 degrees Celsius equals 127 plus 273 Kelvin, making 400 Kelvin. While the initial pressure P1 is given to be 300 Newton per meter square. Also, we are given the final temperature to be minus 73 degrees Celsius, which is equal to minus 73 plus 273 Kelvin, giving us 200 Kelvin, while the final pressure is 120 Newton per meter square. So the question asks us to get the ratio of the final volume to initial volume. So as usual, we proceed to substitution of the parameters of the given parameters in the mathematical expression for general gas equation. So using P1 Phi1 over T1 equals P2 Phi2 over T2. Our P1 in this case is 300 Newton per meter square times Phi1, which is unknown, over T1, which is 400 Kelvin, equals Phi2, which is 120 Newton per meter square, times Phi2, which is unknown, over T2, which is 200 Kelvin. Then if we cross multiply, we have 300 Newton per meter square times Phi1 equal 300 Newton per meter square times Phi1 times 200 Kelvin will be equal to 120 Newton per meter square times Phi2 times 400 Kelvin. Then we can divide through firstly by 120 and 400 Kelvin, and later in the second step divide by Phi1. So and that will lead us to Phi1 over Phi2, which will be equal to 300 Newton per meter square times 200 Kelvin over 120 Newton per meter square times 400 Kelvin, making the ratio of our Phi2 to Phi1 to be 4 5/4, making our answer to be 5/4, which is option B. Now on to practice question. The first question here for your practice comes from UTME 1985 number 12, and the question goes thus: a quantity of gas occupied a certain volume when the temperature is minus 73 degrees Celsius and the pressure is 1.5 atmosphere. If the pressure is increased to 4.5 atmosphere and the volume is halved at the same time, what will be the new temperature of the gas? Option A is 537 degrees Celsius, option B is 327 degrees Celsius, option C is 300 degrees Celsius, while option D is 110 degrees Celsius, and option E is 27 degrees Celsius. Then the second question here for a practice comes from UTME 2012 number 21, and the question goes thus: 2000 cm cube of a gas is collected at 27 degrees Celsius and 700 mm mercury. What is the volume of the gas at standard temperature and pressure? So standard temperature and pressure. The option here, option A is 1896 cm cube. Option B is 1767.3 cm cube. Option C is 1676.3 cm cube, while option D is 1456 cm cube. Now, the hint on this question is that the standard temperature is 273 Kelvin, while the standard pressure is 760 millimeter mercury. I repeat, the standard temperature, which will be at temperature 2, T2 here will be 273 Kelvin, while the standard pressure, which is our P2 here, will be 760 millimeter mercury. Now, the expected answer for question 1 is option E, while that of question 2 is option C. Now, our next video will be on ideal gas equation with sample questions and solutions from UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lectures on subjects relating to UTME and SSA. Thank you.